Okay, guys, looking at 2.3 day 2, and I took the liberty of going ahead and inputting a couple of things in the handout already so that the video could be a little bit shorter. So you'll see some things I've already pre-populated here. First question is, as a review, are all rectangles also parallelograms? Well, first thing we have to ask ourselves is, what is the requirement to be considered a parallelogram? You need two sets of parallel sides. And then we ask ourselves, does a rectangle meet the minimum requirements? Yes, rectangles have two sets of parallel sides, so therefore they are also parallelograms. So again, for the sake of time, I've already cut and paste this in here for you now very quickly. You can pause the video and record that. So yes, rectangles meet the minimum requirement of being a parallelogram because it has two sets of parallel sides. Next question asks us to sketch. Remember, sketch is just a quick and dirty draw. It doesn't have to be perfect. You don't need to get your ruler out necessarily. You have a ruler in front of you, hopefully, so you can use it. But if you're sketching a scalene triangle, just remember it has all three different side lengths. That's what a scalene is. If it has three different side lengths, it's going to have three different angles as well. So to sketch the altitude of that, I would just draw a perpendicular line. Remember, the altitude is a perpendicular line, and do that right there. There you go. And that is the altitude of a scalene triangle. Okay, sketching the right bisector of line segment AB. Here, I would expect you to use a ruler, but if I want to sketch the right bisector, remember, there's a couple of things we have to remember when we're labeling. It's very appropriate. The line segment's already drawn for us, and I've got the midpoint kind of marked out there with a letter A. That's the midpoint. Let's get back to the screen there. And if I notice the slope of this line just by inspection, because remember, we're doing a sketch. If I look at this, if I want to follow one grid point to the next grid point, I notice that it goes up one and right two, up one, right two. So if it goes up one, right two, my slope is a half, but I'm supposed to be drawing or sketching the right bisector. Remember, right means 90 degrees or perpendicular. So if it's perpendicular to 1/2, the perpendicular slope is what ended up being, and we draw perpendicular like that, right? We label it like that. Perpendicular slope would be -2. Flip and change the sign, or negative reciprocal. Okay, so I know the midpoint is right there because I identified it earlier. And the slope, the perpendicular slope is -2, which means goes down 2 and right 1, or up 2 and left 1. So I could do that line, draw the 90 degree, and then it's very important to make sure you put your hash marks on either side to show that A to the center and from there to B is also the same length. So the hash marks prove that for us, and that is a proper sketch labeled, okay? You might want to put an arrow on either end of your line because it said sketch a right bisector, but arrows go, the line goes infinitely in both directions. So there we go, okay? The learning goal is the same as last day. We're spending 4 days on 2.3, so that hasn't changed. The points A, 5, -3, B, -2, 4, and C, -1, -7 are vertices of a parallelogram ABCD. Find the coordinates of vertex D. So I took the liberty of going ahead before I started the video to draw an A, B, and C and label them. And basically what we're looking for is we're trying to find the other coordinate of where D should be, basically something like that, so that we've drawn a perfect parallelogram. So we really only need to find one coordinate here. How do I find the coordinate? There are multiple ways of approaching this, but one that I thought would be pretty easy would be, let me find the slope of BC, because in a parallelogram, those sides run the same direction because they're parallel. So if I know the slope of BC, that's going to have to be the same slope as AD. And so let me find that first. All right, so y2 minus y1 for BC is going to be 7 minus 4. And you might want to pause the video, try this by yourself, see if we get the same slope if you're getting your integers done correctly. And there's probably one of the most common mistakes is going to happen right there when we do x2 over minus x1, the -1 minus -2. The most common mistake ends up being with the integers. So but 7 minus 4 is 3, and -1 plus 2 is 1. So it's 3. If my slope is 3, we don't want to leave it as 3 over 1 because it's inappropriate, right? Not the best form for math. If the slope is 3, then what I could do is find D by saying Let me just double check that, by the way. So if my slope is 3, it means go 1, 2, 3, up 3, right 1. Perfect. It worked out. So I know that's correct. And so I'm going to go 1, 2, 3 here and over 1 to the right. And that would put D right there. It's hard to draw on this computer, but there we go. That looks about right. Looks like a parallelogram. So I'll label it D. And parallel, remember, if you were sketching this properly, parallel would be like this, right? That would be single arrow, showing that they're parallel sides. Okay, so that's one way of doing it. Another way is you can try and find the POI, find the equation of CD. So this is another strategy that some people might use. You can figure out the equation for that line right there by finding, sorry, you can get the equation for that because you know it has the same slope as AB. So the same slope, and we also know that the highlighted line passes through the point C. We can use that coordinate and solve for B, and we can write an equation for that line in y equal mx plus b format. We can actually find the equation of AD, even though we don't know D, we can find the equation because it has the same slope as BC. So we take that slope and then sub in coordinate A, and we can solve for B. That's a lot of work though. There are many steps to that and would take you many, many more minutes than just doing the slope formula. So I'm just showing you the path to least resistance. That's the way I would do it. So keep that in mind. Again, but there's many strategies in your arsenal at this point that you can use. You just have to know which ones to take out of your tool belt. Determine 3 coordinates that make an isosceles triangle and use analytic geometry to show its isosceles. So let me just see what I did in the answer key for you guys. All right, if I want to draw an isosceles triangle, I could start off at, I think I'm here, I started at 6. So let's try that. I go here and I can go all the way to there. Just kind of, yeah, there we go. That's not going to be good. There we go. Okay, I think this is more, if I think about this, is probably a little bit more accurate on my answer key. But nevertheless, I'm going to prove that that side is equal to that side. How do I prove that? Okay, well, first things, I'm going to use length of line formula. I can use length of line formula, right? To prove isosceles, I can find the length of this and find the length of that using the coordinates given. And I can prove that those two side lengths are the same. That's one strategy, and go for it, get it done. Another interesting strategy, I'm purposely showing you something different again, but isosceles, 2 length of line formulas, probably really easy to do. This is A, by the way, this is B, and this is C. So I can find the length of AC, find the length of AB, CB, or BC, and done. Another strategy, again, just to throw it out there so you can know, you can use the Pythagorean theorem. If I draw a line down the middle here, technically that's a median, right? If I draw a median here, I know that I've now created 2 right triangles. And if I plug in, if I use the Pythagorean theorem, then I should be able to prove that this side equal this side by the Pythagorean theorem. All right, and here's how it would go. If I know that C squared is equal to A squared plus B squared in the Pythagorean theorem. In this case, I'm going to find out that AC squared, right, I'll put in bracket, AC, the length of AC squared has to equal, and I'll call this A, and I'll call the height B. So A squared is 6 units long, so it's 6 squared plus 6 squared, because this side here is 6 and that side there is 6. So I know I can do that. That's pretty quick, easy numbers to work with. And then I get equal 36 plus 36. AC would be the square root of AC squared. So let me shove that in there. The square root of that and the square root of that. I just got to change that to AC. Square root of AC squared will get me AC, and that ends up being root 72. I know I showed you in the last lesson how to simplify that further, but right now that's good enough. We're just proving that they're isosceles. And then the next one, I'm still going to follow C squared equal A squared plus B squared, except this time I'm doing BC squared equal A squared plus B squared. But it's the same over here. That's 6, and the height is still 6. So basically we're dealing with the exact same thing. Then I know the square root of BC squared is equal to the square root of, it's really going to come out to 36 plus 36. Let me show my work. It's going to be 6 squared plus 6 squared. And I'll square root that all right now. And I can jump to BC equal square root 72. I've already done the work over here. So it's kind of common sense. It's going to be the same. So I skipped a little bit, but not that much. Okay. We've proven, and you can say, since, upside down therefore is since AC, line AC is equal to line BC, that's an easy communication, therefore triangle ABC, let me see if I have room here, is isosceles. Okay, and there's my important statement at the end. All right, last question. -2, -3, and 6, 9 are the endpoints of the diameter of a circle. Did a question like this last day. So -2, -3 is right there, and 6, 9 is right there. You can draw the circle. You don't have to draw the circle. It's gonna be a little tough. Let's see if I can do it with this computer. It's not the greatest, but I should be able to shrink that. See if it lets me. Almost. Okay. Let me see. One more. Close enough for me. Okay. So we've got that. That's the endpoints of the diameter of my circle. And it wants me to determine the center of the circle. Well, the center of the circle, you know, the diameter runs, is where the math language is important. It's a very simple question. A diameter has to run through the center of a circle. Otherwise, we'd call it a chord, right? If the line went from touching the circumference to touching the circumference, that would be a chord. But if it passes through the center of the circle, then it's the diameter. So really, we just have to find the midpoint of that line. And I've got it. I got the midpoint formula written here. So x1 plus x2 is going to be -2 plus 6 divided by 2, and -3 plus 9 divided by 2 equals, we could skip steps here, -2 plus 6 is 4, divided by 2 is 2, and that's 6 divided by 2, which is 3. So let's take a look, 2, 3, because my sketch is a little bit off, but ballpark, that's looks like I got close to the middle there. Again, my circle is a bit wider there, but you get the hint. Algebraically, or using analytic geometry, we've determined the center of that circle. All right, you guys can hit the homework now. God bless. Talk to you soon.